Hello, welcome back to our series Securing Cyberspace. I'm Friederike, Editor-in-Chief of the Cloud Report, and of course I'm joined by Joland, Chief Cybersecurity Officer at Cloudical.
Hello.
Last time we talked about cloud computing and security, and we ended with the challenges of cloud computing, and security is one of the big challenges, but Joland concluded that also vendor login is a problem in the area of cloud computing. And this leads us directly to our topic for today. We talk about open source. And for that topic, we invited our guest, Karsten Samaschke, CEO of Cloudical, and expert in open source. So that's why we asked him, what is open source?
Good morning. Glad to be on the show. Okay, so open source. Open source is best described as pretty much the opposite to closed source, to proprietary software. Open source is basically a principle where you lay out and lay open the source code, as the name applies. The idea behind that is that you give others the chance to review the code before using them. It's public or it's a popular misunderstanding of open source that open source has to be free. Doesn't necessarily have to, but the point is that open source is, as the name implies, open. Everybody can look into that and can understand whether there is telemetry in place, whether there is some secrets going on, whether there is some strange thing happening. And then basically another principle of open source is that not always, but typically, at least in the bigger projects, pretty much everybody is invited to contribute to those projects. So you have that kind of crowdsourcing, that kind of community thinking, that kind of shared responsibility. And speaking of security, that gives a very major difference compared to closed source. With closed source, you always have that kind of I hide it behind principle. With open source, you lay it open. Everybody can see security issues. Everybody can report security issues. And it's not like just hidden away. It is just there and it is able to be fixed. And that's why, for example, Linux, Kubernetes and many other projects are open source projects, and they are considered to be way more secure than traditional closed source projects.
Okay, to stay more in the general context, what are advantages of open source in comparison to closed source?
You need to factor in that there are different licensing models for open source, but generally speaking, it's the openness of software. You can see what the software does and what it doesn't. You can get an understanding of the quality of the code that is used there. With bigger projects, you can contribute yourself. You, depending on the license, have the right to fork code, to basically take a version of the project, take a version of the software and use it on your own, change it, adjust it to your liking, and then you can either contribute back or have it as your own kind of product up and running. So you are not vendor locked, you are not locked in, you are not trapped in. And even if the original vendor or the original project decides to go a different route, you are not bound to that. So you have way more freedom. You have way more, perhaps even compliance. You have way more transparency. You can have way more security. You can have or will have way more responsibility if you fork code. But the basic difference and the basic advantage is that the code is, again, depending on the license. There are also very restrictive licenses on the market, but typically the code is laid out. You can look into that, you can understand what's going on, and you are not confronted with some sort of a black hole. And that is on so many levels a true advantage over closed source and over proprietary software, that it is basically a value on its own.
Okay, I see. And I'll go more into our topic. Karsten mentioned it before, but Joland, what means open source regarding security?
Yeah, so thank you. So Karsten already opened the discussion, and that was great insights already. What it means open code. So you are able to look at the source code, and especially what Karsten also mentioned, the community, the crowd contribution. So there are many eyes looking into that code, and they have also, I would say, different interests into the project. While with a closed source, when you have only, let's say, a dozen of people working on the project that have maybe the same interests, they are, let's say, under the same company, and they need to achieve the goals of, as we know in the world of DevSecOps, where everything needs to be faster and faster and faster. So they might lose, or they not, let's say, intentionally, but unintentionally, they might oversee any bugs or any vulnerabilities there are in the code, or they might accept some of them due to the different goals they have. While in the open source community, having these different perspectives, having these different people all around the world, that they have not monetary interest in the first place to the product, but they have interest of contributing to the community, contributing to the public, enabling the public to use the solutions in many different ways, as also Karsten mentioned, like forking the project, creating a different flavor of it, adapting it to your needs, and not being vendor lock-in, not being locked into following the route that the original project developer or the original company that offered that solution is going. So with that, it provides you a lot of advantages, finding vulnerabilities on the code level. You have many different, not only interests, but also expert levels. So in a company, of course, you are bound to the expert skills that you have in your company. And the people are probably very good experts. However, there is a saying, unfortunately, I don't know how to say it in English, but in German, we have the saying of betriebsblind. Maybe you guys can help me to
You
say
are
it.
to some extent vendor locked into your own kind, into your
Yeah.
own kind of thinking. It's basically not being able to think outside the box.
Yes, exactly. Thank you for that. So that was actually what I wanted to say. So you are not thinking outside the box, and if you are from a different perspective, you come from a different perspective with different goals, your own and also for the community. This helps improving the source code, improving the code at the code level of, let's say, making as less mistake as possible on the source code level. Yeah.
Perhaps if you allow me one thing to say, you said it's typically community driven and it's pretty much open. But let's not forget about one thing. Open source is also a very commercial aspect and a very commercial approach to things. I just want to make that clear. Many big companies such as Google, Amazon, even Microsoft have many open source projects. They contribute to those projects because what open source truly is about sharing, is about working on things jointly. So you even leave behind those kind of corporate boundaries there. Different companies, different organizations work on the same projects from different angles and different perspectives. And add to that mentioned out of the box thinking and bringing in different perspectives. And that is very important for the software per se, as well as for a security aspect.
All these advantages leads me to the question, is open source more secure than closed source?
That is a good question, but it's difficult to answer. So it's not always true. What we, together with Karsten, we listed a number of advantages that you might have while going open source, and not to forget the last one that was mentioned, the commercial one, which is probably the most important one. And security, it's, let's say, a side process going through and being integrated into the developing of that project. Nevertheless, you have to think about Maybe I can bring an analogy here, saying when in security we know the Kerckhoff principle, which is about cryptographic algorithms, and the Kerckhoff principle says that the security of cryptographic algorithms should be based not on holding the algorithm secret. So the algorithm itself should be public, should be checked by experts of the field, while the security of those algorithms, of the security of that crypto system, must be based on the secrecy of the cryptographic key that is being used. And this has, I think it's a good analogy also comparing the open source to closed source. While open source, everything is open, so experts can look on that and maybe they can find any problems or vulnerabilities that might be in the code, be those intentionally or unintentionally. And on the closed source side, well, this is the so-called security by obscurity. So you have some security also in place because it's obscure. So it's difficult for you to find vulnerabilities because you need to reverse engineer the code. You need to go into the machine level of the code, into the assembly, and disassembly the code while it is being run, and then identify vulnerabilities. And this is how it works in the world out there. So people disassemble the code, they reverse engineer, they identify bugs and vulnerabilities for a system where you have a closed source. However, it's also important to be mentioned that this doesn't mean per se that closed source it's less secure than open source, because you might have also closed source system where people are very skillful about what they are doing. They are the best expert maybe in the area anyway, so they know what they are doing. So this it doesn't imply the one or the other. You must only be aware of what are the risks and what can go wrong. However, one thing that is why I'm saying this is because at the end of the day, it's not the code that you're seeing and that you are analyzing that it's going to be run on your machine. So the open source means, so this is the code that actually is going to be compiled on the machine code, or into a machine code that is going to be run on your machine. So there are two different things. So we are talking about two different things here. So this needs to be clear that it might be that you will get any vulnerabilities afterwards, after your code has been compiled into machine code. So there are vulnerabilities that can well rise after actually you compile the code. So and this is something why you still have the same issues that you might have even in the closed source environment.
Can I just bring in one thought? And Joel mentioned it. First of all, security by obscurity is never a good measure. Secondly, it should be secure by the approach and not by hiding away information. And with open source, and that is the thought I want to bring in. With open source, you don't have per se a better security. Perhaps you have even a perceived worse security, but that is due to the fact that the code lays open, that everybody can look into that and that everybody can contribute to that and can work out security issues and make them transparent. So it's again a matter of transparency there that is very important. One last thought on that very shortly. As Joel already said, I just want to underline that it basically depends on the skill level of the people that are working within the project. So you can have a very, very secure proprietary software in a very insecure open source environment, but chances are with a good open source environment, with a good open source community, you are more secure than with a proprietary approach, because the impact, the influence you get from the outside could be way more diverse. And diversity is a very, very good thing in that. Open source can be more secure, doesn't necessarily have to. It always depends on the people and on the project and on the way it is stuffed.
Okay, just the last question from a non-technical perspective. When Julian mentioned it before, when open source is free to access and you can see and look at it in repositories, why do I need passwords or access control to use it?
Yeah, so the idea is here, security has different goals. And one of them is, for example, confidentiality, and the other one is integrity and authenticity, so, or availability. So, and why you need access control is about integrity of the code. So you have a project where a lot of people are contributing into it. And when you contribute on open source project, there is also a code of conduct, meaning rules that you have to follow for contributing into the project, rules that you have to meet and fulfill for being able to contribute to the project. Because being open in a sense of not being confidential, that everyone can have a look at it and everyone can give their opinion on how you can improve, is different of everyone is able to do whatever they like at the same time, while maybe doing something unintentionally wrong, and inserting backdoors, which are very difficult even for experts to identify, because those backdoors might not be on the code level, but they rise afterwards, after the code is being compiled into the machine code. So there are very obscure things that you can do. And for preventing this, of course, you have access control for enabling and for fulfilling the integrity of that code. And so that is the main reason behind that.
There was just recently a case where some scientists from an American university tried to find out what happens if they put malicious code into, I think it was BSD's repositories. And the problem with the big projects, for example, is that there are so many code changes. They all need to be taken care of. They all need to be reviewed. And that is basically something that is very hard to accomplish. So chances are that you are getting too successful as an open source project, that your processes and that your approaches might not be able to execute on the same level of speed as, for example, the code contributions. So that leaves a delta for malicious code attacks, for negative things to happen. So it's very important to ensure that just those who are trusted are able to actually contribute. I mean, it's the same as having a password or having some sort of authentication for your bank account. Might be secure, it might be pretty nicely laid out from a technical perspective. Nonetheless, you don't want to have anybody have access onto it without your permission. So you want to ensure that the data, the things in there remain there as long as you like it. So it's pretty much the same principle. Access control and confidentiality are very important aspects, and they do not contradict the idea of open source. You can look onto code, you can contribute, but always according to rules. It's not anarchy. It's a very controlled and very straightforward approach that is required to ensure that all the good things that are in there are actually good things and not malicious things.
So it's another step towards secure open source code. So yeah, thank you, Karsten, for the insights.
My pleasure.
Awesome.
Julian, it was a
Glad to have you.
great next episode of our series. And next time we talk about key management systems, a deep security topic. I'm looking forward to it. Thank you.
Thank you. See you next time.
Thank you. Thanks for having me. Bye.